Hello, and welcome to this Alexa Tech Talk. Do you want to learn how to build more natural conversational skills for your customers? My name is Sam Ingbar, and I'm a senior solutions architect on the Alexa AI team. I also enjoy running and flying in my spare time.
Hi, I'm Premraj Rengaram, and I'm also a senior solutions architect as part of the Alexa AI team. And I'm also a serious hobby USTA tennis player.
Today, we're going to be providing an intro-level talk on the Alexa Conversations Description Language, or ACDL. Our goal is to give you a foundation for exploring this language further on your own and in your own applications. Today, we're going to cover 5 different topics. First, we have what is Alexa Conversations. This is important because it's context for ACDL, which also utilizes Alexa Conversations to power its skills. We'll give a little bit of a background on Alexa Conversations-based dialogue management. Second, we'll talk about what is ACDL. In this, we'll talk at a high level about what the language is and what it does and how you use it. The third section is who is ACDL for. This is not just about which developers ACDL is for. It's also about what kinds of skill use cases are best for ACDL. Fourth, we'll talk about how ACDL actually works. In this section, we'll get into some of the meat of the core keywords in the language and how they work together to build skills. In the 5th section, how to get started, we'll provide a few different ways for you to get your hands on ACDL for yourself and start learning more. To start off, I want to take a brief look at Alexa Conversations and conversational AI to give you the necessary context to understand ACDL and the environment in which it exists. Alexa Conversations is a dialogue management tool in the Alexa Developer Console. Dialogue managers are tools that we use to let the skill layer decide how to respond to the user instead of requiring the developer to define this in their code. Alexa Conversations is unique as a dialogue manager in that once enabled, it is always on and interprets every single incoming utterance rather than just specific intents. This allows us to use conversational AI to interpret each incoming turn in the context of the entire preceding conversation. This brings a couple of different benefits, such as context carryover and moving between features more easily for free. It also reduces the code burden for developers significantly. These features help developers tackle a complex problem in building voice experiences. When creating voice experiences, developers are often designing for a set of use cases that they think up early on in the process, and those involve the user saying a specific set of utterances in a certain order in order to have a successful interaction. These utterances end up very well supported, especially with interaction model-based skills, which are set up well to handle this type of interaction. We call this the happy path. However, customers often deviate from the happy path, and a lot of the effort in voice development goes into bringing users back to the happy path after a deviation. Alexa Conversations helps to manage that process. By looking at the entire conversation and when it's deciding how to respond to a given turn, it's able to better steer the user back towards the happy path.
Now that we've learned a little bit about Alexa Conversations, let's take a closer look at Alexa Conversation Description Language. Alexa Conversation Description Language is a new language which is being used for writing Alexa Conversations powered skills. Now, meaning that this ACDL is going to replace the work otherwise you may have to do through the Alexa Developer Console. In both the Developer Console and in ACDL, skills are built around a core artifact called a dialogue. As we saw a moment ago, in the Developer Console, skill artifacts annotate conversations in pretty much full text format. In ACDL, dialogues are represented as a sequence of events and associated actions which are tied to it. As you can see, both of these dialogue variations, one built via the developer console and then one built via the ACDL through the IDE, both basically get trained very similar at runtime and provide similar behavior for the end user and provide a similar CX as well. Though the DX, which is the developer experience, is slightly different from the UI perspective on one angle and from the IDE perspective on the other angle. So there are a few, I would say, benefits specific to ACDL-based skills. Dialogues, I would say, are more flexible. in ACDL compared to the developer console. And in the developer console, there are like few validation rules which force developers to kind of tie certain terms in a specific order, and the dialog acts should be in a specific order, and so on. But because the dialogues are written more in a way that mirrors our system level APIs in build tools in ACDL, the dialogues are not bound by the same limits. For example, we can define dialogues where an utterance set with the required argument that is only valid as a follow-up response to a specific proceeding term, such as what ingredients in response to a recipe recommendation. And to do the same thing in developer console, it's pretty much not possible to define a contextually supported utterance set in the training data. So that's what I would say. It slightly differs and gives you an edge over authoring capabilities. And the other benefit I would say is more like enhanced conversational branching. Dialogue branching can pretty much happen at any given turn based on any argument that is instantiated during a dialogue. And in the developer console, branching today is actually limited to response payload values on the API success term. That might change in the future, but for now, ACDL gives you additional control over different branching capabilities, which you might need at the middle of different turns or at the post-process, pre-process of any turn, basically. The last but not least, I would say that you can pretty much easily import, reuse, and share your ACDL skill assets. You can even break up your ACDL skill assets into different files. And you can pretty much also reference these as referenced types, which could be leveraged across different ACDL files. So let's say you have a shared services team which kind of develops core artifacts, and they want that to be kind of frameworks or patterns. So they could develop those as reusable assets and can be shared across different teams as well.
Next, let's talk a little bit about when to use ACDL. There are different trade-offs between working in the developer console and working in your integrated development environment. But ACDL, as we've already talked about, is only usable within the command line. So if you're considering using ACDL or developer console Alexa Conversations, it's important to think a little bit about the trade-offs between those two different options before you decide to try out ACDL. Because once you convert a skill into ACDL, you're no longer going to be able to edit it in the developer console again. And so you need to be sure that that's what you want to do as you go down that road. So the first question to consider is who should use ACDL? ACDL is definitely for a lot of developers, but it doesn't mean it's for every single developer out there. One of the main reasons for this is that ACDL replaces one-to-one mappings between artifacts in the developer console with many-to-many relationships, and guardrails that exist in the developer console are removed in ACDL partially to help facilitate these many-to-many relationships. This, as you can imagine, creates a lot of flexibility for developers who are used to navigating Alexa Conversations-based skills, but it also introduces a number of new ways to break things by accident. And so my sort of personal advice to developers who are totally new to Alexa Conversations is that spending a little bit of time in the developer console before you try out ACDL will do you good. But that being said, it's not always the case. And so I would say there are probably 3 questions to consider to figure out, are you somebody who will benefit a lot from ACDL? The first question is, do you prefer working in your own development environment, or do you work on a multi-developer team? In both of these cases, it's probably going to be easier for you to work in your IDE than in the developer console. In particular, with multi-developer teams, being able to store your skill in a code repository and have multiple people push to that code repository is going to be a big advantage over trying to share a developer console account. For question 2 is whether or not you're comfortable with programming language concepts like inheritance and data structures. You're going to need to learn those concepts to really wrap your head around ACDL. And so if you don't know them already, you're going to be taking on learning those as a part of taking on ACDL. Third question that I would encourage you to ask is whether or not you already have some experience with Alexa Conversations already. And I mentioned this just a moment ago, but the representation of your end customer experience, what you're actually building in ACDL, is significantly more abstract than in the developer console because you're not writing out these language-based dialogues and annotating them, so you don't get to see that combined picture in human readable language in the same way that you do on the developer console when you're building an ACDL. This helps you just learn and understand how these skills work. And so for that reason alone, I would say it's definitely can be a good idea to spend a little time in the developer console before you move over to ACDL. So if you've answered no to some of these questions, then the developer console is really going to be a great choice. And for developers who maybe answered yes to all of these questions, or are really comfortable with programming languages and have their own very specific development environment already set up, ACDL is going to allow you to build a more complex skill, and you're going to be able to do it faster. There's also a second question to answer here, which is what types of skills are a good fit for ACDL? And in general, skills that are a good fit for Alexa conversations are still a good fit for ACDL. And these can be lumped into three categories. The first category is task-oriented skills. And task-oriented skills are skills where the user is trying to accomplish one or more tasks via voice. And an iconic example of a skill like this would be like a ticket booking skill, where you need to collect a number of inputs in order to accomplish the task. The second type of skill that does really well with Alexa conversations and with ACDL are search-oriented experiences. And so these are skills where the user is going to be searching through a catalog of products to buy or music or whatever it may be, and also wanting to then ask refining questions about the different items that their search is turning up as they go. And so an iconic example of this is like a recipe search skill. And as we get into our sort of example skill later in this talk, we've built a very, very simple version of a skill like this. But that's I'd say an iconic example of what this can look like. The third type of skill is a form filling skill. And these are skills, or sometimes, a feature within a skill, where the user is filling out a complex form like settings. So maybe one example of what this looks like is, let's say you have like a skill that is like provides TV guide information for the user, but you need them to fill out their region and which services which like TV services they have, and XYZ before you can actually give them good advice. And so they need to do that. It doesn't really matter what order they give you the information or anything like that. You just need to get it. Well, that's another place where Alexa conversations can be really useful compared to the interaction model.
Okay, now that you know kind of when to use ACDL, what kind of use cases to use ACDL, let's say you now are moving to the next stage on, okay, I do have a great use case I can think of where ACDL could be a good fit. All you need to know now is like, okay, how do I develop it in ACDL? What are the steps do I need to do? Before we go any further down, going into how to building ACDL, I would first stop by and see, okay, well, how does an ACDL project look first? How does a folder structure look? So as you might see here, a skill package, I would say, in the ACDL folder is the primary core subfolder under the parent ACDL directory, which contains all your ACDL files, your APLA files, which are all needed basically to train the models and to present the data to the customer through the Alexa devices when the response comes back from the backend. Now, this skill package is pretty much where you will be spending most of your time creating all those artifacts. And the conversation subfolder under this skill package is where you will create your ACDL files, which pretty much, I would say, combines or connects all the dots, which could be your utterances, your other ACDL files, your APLAs, and has your primary logic. It also defines data types. So I would say that's the pretty core important asset or / component in the entire ACDL project, which resides under the conversation subfolder under the skill package, pretty much. And the interaction file data, basically based on your locale, it could be in US, in GB, based on, again, like I said, the locale, will reside under the interaction model folder. And you will then pretty much, as a developer, once you develop your ACDL file, your APLAs, which are used for the response prompts, and whenever you're ready, you basically will run the AskX compile, I would say, first, which basically will give you all sorts of validation errors upfront by the line numbers and also by the error type and the error messages. And you can pretty much narrow down to the line number and kind of walk through. It will be self-serviceable, and it has saved, I would say, countless hours of development from the developer console developing a skill versus a CLI, where you can see all the errors in one given shot. Instead of clicking an X, pop-up bubble box on the UI one by one. So that's a big advantage, I would say, using ACDL in the CLI and compiling it. And once, let's say, you compile it and it all looks good, then when you build it through a deploy file, the deployer picks up all your ACDL assets, converts it into an intermediate format called ACAR, stands for Alexa Conversations Intermediate representation, and those are the files which are actually sent to runtime. And basically, they are used to train the model and also, create all the simulation data based on the dialogues you have provided, and it will generate thousands of variations for every dialogue you have provided. So let's quickly take a look at the demo, which Sam is going to illustrate now, which shows how the ACDL assets have come together to form a conversational skill.
Hi, everyone. I have a serious problem, and I need some help. I want to cook, but I don't know what to make. Maybe Alexa can help. Alexa, open Cuisine Explorer.
Welcome to Cuisine Browser. I can tell you about different dishes from a variety of cuisines.
This is perfect. Alexa, do you have any Bavarian cuisine?
One of the recipes I recommend from my catalog of Bavarian cuisine is Bavarian bouillabaisse.
What are the ingredients?
The ingredients are 2 shallots, 2 garlic cloves, 200 grams of waxy potatoes, 2 carrots, 150 grams zucchini, 150 grams fennel, and 4 crayfish.
No, that's not what I want. Alexa, do you have any Caribbean cuisine with chicken?
What cuisine do you want me to find a recipe from? If you aren't sure, I can also give you a list of the available cuisines.
I want Caribbean cuisine with chicken.
Sorry, I didn't find Caribbean in our standard cuisine database. Do you want me to check the rotating list of special cuisines?
Let's check the list. Yes.
One of the specials I recommend from my catalog of Caribbean cuisines, Caribbean jambalaya. The ingredients are 4 boneless, skinless chicken thighs, 12 ounces cured andouille sausages pre-cooked and sliced, 1 diced yellow bell pepper, 1 diced red bell pepper, 1/2 of a diced medium white onion, and 2 stalks of diced celery.
That sounds pretty good. Alexa, stop.
Goodbye.
So as you saw in the demo, first the customer actually opens a skill through an Alexa device with its invocation name. And a welcome message is actually displayed from the skill with its suggestions on how the customer should interact, about options do they have, so that they kind of guided pretty much. And so this happens through the custom interaction model, and also the response is defined and built in as part of your welcome response file as well in ACDL. Now, as the user elicited, show me Bavarian cuisine. This is a user turn where the cuisine category is actually understood by the Alexa runtime and is provided as a user provided slot to your backend API. This entity resolution happens at runtime for you. Now, the backend API then gets this value and returns back a response, which is then converted into a response form, I would say, built via APLAs, which stands for the Alexa Presentation Language audio file. And this is then actually read by Alexa device back to the end user. Now, if the user then asks for, okay, that sounds interesting, can you show me the ingredients or tell me the ingredients for that particular cuisine? Now, Alexa Conversations remembers that the user already is talking about the Bavarian cuisine. So it remembers the cuisine type in memory, which happened in the previous turn. So it's not going to ask the user again. And it also remembers that the particular type of data on the backend, if it needs to be held in memory. And so as a result, it's able to pass this information which it already knows and what the user is actually asking now, meaning like, tell me more ingredients. Both of these are actually kind of passed back to the action prediction, I would say, runtime component in Alexa conversations, so that the ingredients API, which is a separate API in the second turn, and it gets all the context, basically what's happening with the user, what did they say, what already happened. And so now the model, which is actually trained based off all the sample dialogues which the developer actually had created in their ACDL file, and it gets trained, like I said, thousands of variations gets trained or gets generated, and then the model trains. The model then at runtime tries to predict, okay, this is what the user first said, and this is what the user has now said or is asking for, and I know already what they're trying to do, and I'm going to predict probabilistically. So the model predicts what the user wants, and it tries to put together all of the data, and it provides a recommendation basically in the response, and then it reads out, in this case, a list of ingredients for a particular cuisine type across multiple turns. So this is where kind of conversations pull together different contexts which already happen, and reusability, all of that happens at runtime. This whole conversation which happened through multiple turns and context which got preserved is actually shown here in this slide, where it's built out as an ACDL with all these assets, combined together and written in pretty much ACDL language. And this is how it looks as a sample. Just because, dialogues define the skill behavior, it actually doesn't mean that's where most of the work for the developers happen. All the core ACDL components, I would say, are referenced in this dialogue, are now highlighted, as you can see in the slide. And each of these items are actually outside of the screenshot. But before we actually try to understand the composition of this dialogue, let's take a brief look at the dependencies, because those are the things which are needed for an ACDL skill to make sense, while at the same time it's actually more modularized and has a structure. So different team members or sub-teams can work on different artifacts within ACDL.
There are 4 ACDL keywords or artifacts that are at the core of the language and that we want to dig into today. Types are the first of these 4, and they're equivalent to data type representations in any programming language. And they serve a variety of different functions. Probably the most notable, although certainly not the only function, is that they define the data structures for request and response payloads, slot values, and any other data structure that exists in your skill. The second type of keyword or artifact is events. And events are roughly equivalent to utterance groups or utterance sets for anybody who's familiar with the developer console experience. But for someone who's not, basically, these are defined as a group of utterances, which we'll see in just a minute, that the user might say, sort of attached to a trigger. So if the user says one of those things, then the event is triggered. And the third type of keyword or artifact that we define in ACDL skills are actions. And actions are always triggered by events. And so they're sort of paired together. And actions are where we define what API handler is going to be invoked when the action is triggered by an event, and also how to respond to a given event within the context of an ongoing dialogue. Finally, the fourth type of artifact that we have in ACDL is the dialogue. And the dialogue, like in the developer console, is the unifying artifact where all of these pieces come together. But of course, it's represented quite differently in ACDL compared to the developer console.
So the ACDL types, I would say, define data structure, just like in any other programming language of choice, be it Python, C, C++, Java, and so on. They are declared, meaning the data types in ACDL are declared with the keyword called type, and it's a reserved keyword. With that, you can actually create 3 types of data types. One would be the built-in types, like string, Boolean, and so on. And then you can create your own custom types, where you can pretty much create your own structure, the request response object, and so on. And then you have the third types, which is called the slot types, which some of you might be already familiar with, building through the interaction model and intents in Alexa skills. So I would say the custom type is pretty much where it gets interesting, where the developer can define something related to their business use case, to their context, to their scenarios, and so on. And I would also recommend that you create them in a modular way, and that's where I would say within custom types you can customize the custom types, meaning you can refer custom types across different custom types, and which we are going to see that shortly in the bigger sample and also in the demo, and you will also see it in the sample code, which we will be sharing across shortly. And the slide shown here actually as an example shows that cuisine category encloses cuisine slot, which is actually a custom slot as its child. And then the second type here, is a child which refers to another custom type called cuisine type response. The third definition here encompasses two optional child elements called cuisine and ingredient. These are the three types pretty much I would say, are used in your turns in the example dialogues which you might build. And I would say throw some highlight on the keyword called optional, because in some cases you may, within the same structure, if it's used across different, let's say, actions or backend APIs, you may want to change the behavior. And there are ways to do that within ACDL using ensure block to kind of make it a mandatory check, or you can just leave it as optional, which we'll see in the sample now. So this slide, which you might be seeing here, actually shows a visual of the connection between the interaction model, in the enus.json, for example, where all your intents and your catalog and your slot values are present, and the type definition, which is actually part of the ACDL file. So, by referencing a slot from the interaction model onto a type actually interconnects them, and they actually are automatically linked at runtime, and the conversations will figure out, okay, so this custom type refers to this slot type actually. And so AC conversations pretty much gives you that flexibility, and this is where the power of where interaction model and your custom types can be hybrid and can be mixed together to have even more benefits. Notice that only one of the types in the first turn is directly referenced in the dialog shown here to define our response payload. The other two actually are linked to the action and response, and they are in fact referenced, I would say, indirectly. And that's what this slide shows you. You might see that a lot might be going here, but it's pretty easy once you understand, the I would say the reusability of those slots which we talked about across different turns is what pretty much is happening here. And also the response sent by the backend is also sent to a response APLA so that it can be rendered in a surface form to the end user via an Alexa device.
On the slide now, you're going to see an event, and events are like I mentioned a little bit earlier, they are groups of utterances basically attached to a trigger that a user might say. And when they're worked into a dialogue, when a user utterance matches with a given event, it will trigger that event, and it's going to launch an associated ACDL action, which will then hit your backend API handlers. And so each event declaration has a type attached to it, which is shown in green on the slide. When there are multiple slots in the utterances in your event, you can also in that block, instead of saying this is slot type A, slot type B, you can create a custom type with both of those, and then use that parent type in the block to allow for multiple utterances. And you can also set some of those fields within that parent type. The subfields within the parent type is optional, so that there are sort of optional inputs within that event. In the case where there's no slot inputs, it's just an utterance with no slots. You can also use the nothing built-in type here to get coverage for that event and avoid any validation errors. Just as a reminder, the dialogue simulator, which we talked about much earlier in the talk, will be generating additional possible variations based on these utterances to improve runtime coverage. And also, the more utterances you're able to put into your events, the richer your coverage will be in general overall. Moving on from events, we should also take a look at actions. In the slide here, you can see the get by cuisine type action declaration. And as I mentioned, when you were talking about all the different artifacts at a high level, actions are counterpart to events, and they are roughly equivalent to the API definition concept in the developer console. They use a type to define the format of the response payload that an API handler is going to provide, which is in green. They specify the name of the action, which will be also the name of your API handler in your code that matches with the action. And they also specify the types from the event that are being passed into the action. So your request inputs. These inputs can also include default arguments. So in the example above, the cuisine name is indicated with the equals and nothing parameter, which is a default argument that actually makes that field optional. And worth noting here, right, is that these actions are not correlated with a specific event, but rather with certain type inputs. And so this is one example of the one-to-many relationships that I was mentioning earlier in the talk, and the way that one action can service multiple events and vice versa. In this slide, we just see the actions in our sample dialog highlighted. And you can see exactly where it goes. So the action is put into our response block in the sample code. And this is where you'll define your action in any turn of your ACDL dialogues.
So the fourth artifact, I would be talking about is the dialogue. Now, the dialogue is a very unique component and an integral component, I would say, in ACDL, in any use case, pretty much, under any sample dialogues you'll be creating, because that is the one which actually pulls together all the components. Dialog contain basically like one or two samples marked with the keyword called sample. And this might change in the near future, but it is part of every dialogue right now. Kind of imagine it's kind of a functional block or a dialogue block or a sample block within a particular use case. Now, one dialogue can have multiple samples, which are all kind of interconnected, slight variations of your use case within a dialogue. So that is, I would say, pretty much how I would look at it. And each sample provides a variation, falling, like I said, on the dialogue use cases. And it almost always begins with a keyword called expect. And it kind of triggers the dialogue turns and starts a conversation. Now, the expect, I would say, action is pretty much related to, associated to any particular event, almost always. And this defines the setup for the first turn of the dialogue. And the second line defines our action and the type and the key for our results. The arguments which are elicited from the user are actually passed to the appropriate API handler based on the parameters enclosed as shown here in the parentheses. In the third line, the result from the API handler is passed back to the skill and is marked by the response keyword. Now, the response is actually, I would say, rendered to the end user through a template called APLA, which pretty much is a file you will create where it has its own audio constructs, video constructs, sequencing, and I would say conditional capabilities built within, which you can refer our tech documentation on that, and we'll also provide those links. And you can author those in the APLA and how you want it to be rendered and so on. And you can also decide whether it's a success scenario or a failure scenario. And finally, the API pretty much needs a payload type to pass into the response data, which is what is actually shown here. Now returning to our example dialog, we can apply now what we know and what we have seen so far. First, the user actually triggers the get by cuisine type event. And then the skill performs get by cuisine type action, which is the backend API, by sending it the value it has collected from the user through the events. And third, the skill pulls back the response from the skill code into the cuisine type response prompt, which is, remember, our APLA. And finally, the cuisine type response prompt, which is our APLA, will use all this data via the payload parameter and will render the data to the user. Now, in the second turn, the user actually triggers another event called get ingredients event, where the user asks for something else different or based off of the previous turn in this case. And the cuisine name argument, which is already elicited and fetched from the user, is actually passed forward to the get ingredients action. So the user is not prompted for it again. And then the response is pulled back from this second API, and the data is sent back into the ingredient response prompt, which is a different APLA altogether. And now that a second APLA will take this data and it will render it in a different way. Now this pattern can be extended to 3 turns, more turns, as many as you want, and can keep having these many different types of APIs interaction, different combination of APIs, and Alexa conversations and ACDL pretty much, runtime remembers the context and what the user is trying to do. And some of you might have noticed in this example that there's an offer block in the first turn. So this is an optional field which you can use, and it's a very powerful feature as well, I would say. And this can be a part of the response of the first turn, and which allows the user pretty much to decide whether to provide them with an additional option. Okay, this situation happened, would you like to proceed, or would you like to go path A, path B, and so on. So many different ways which you can move a dialogue conversation in a natural way, because pretty much when you talk naturally to somebody, they don't go in one particular way. So there are a lot of nonlinear jumps which Sam would have talked about earlier on. So that's what we can do pretty much in this particular area with the capabilities of offer APIs. And this is also useful pretty much where you need to pass, I would say, arguments between different types as well. Now, another way to look at the same, interaction map, which we have seen in the past, more like I would say logically, but now you can actually see what events are connected to, what elicitation happened with the end user and Alexa conversation skill pretty much. So this visual shows pretty much how the building blocks of the interaction based on the assets you built are actually interconnected. Now, I would say if you have, Alexa conversations experience, you may be wondering, wait, how do I handle turns that don't need to interact with the skill code? Now, in ACDL, I would say we focus to make sure that the code is able to handle deviations from our happy path is actually made super concise. Now, in the developer console, this is actually managed by writing, multiple dialogues to annotate the skill behavior in different situations, and also setting required arguments in the API definitions. It is far more flexible in ACDL actually. In the dialogue, as you can see, there is an ensure block. Now, this block is a very key block where you could use it to make the arguments mandatory for a specific turn within dialogue, or multiple turns within dialogues as well, or multiple samples within the dialogue as well. Now, in each request arguments line, the developer is actually defining a mandatory argument and a request argument. This allows the developer to more manage in a better way the mandatory arguments at the turn by turn level, and eliminates the need for adding extra dialogue just to request mandatory arguments. So this gives the full control kind of to the developer to decide how they want to handle it and what they want to handle as how. Yay, we made it. We made it to the end of the technical part of the conversation. Pat yourself on the back, because there are a lot of components we looked at. There are a lot of new terminologies you had to go through, and you patiently went through our demo as well. So we truly appreciate you spending your time on this. And in this slide, we just wanted to show that all the dialogues, the types, data types, I would say the events, the actions, the response templates, the APLAs, all of them come together to make your skill actually conversational, to support nonlinear jumps, to support different use case scenarios where a customer could say yes, could say no, could go, conversation path A, path B, and so on, based on however you want. And we have built all these assets, or provided this framework, capabilities, tools for you so that you can leverage it and build exciting conversational skills. Thank you.
I hope that this introduction has you excited to dig into ACDL further on your own, and maybe even build a skill for yourself. After this talk, there's a few different ways that I recommend getting started with ACDL. And we have a few links here that I think in order are going to be the best way to get started. So the first thing that I recommend that you do is to go to and follow the quick start guide that we've put together. And this will help you set up your development environment and then deploy one of our template skills in your local environment. Once you have done that, my second recommendation is going to be to set up another template skill and try adding your own dialogue or feature to that skill in order to get comfortable with building ACDL dialogues and artifacts and just getting familiar with the way that this language works. And once you've been able to do that, the third thing I recommend that you do, if you're able, is to take an existing Alexa conversation skill that you have in your account and exporting that to ACDL to then try and experiment with more advanced features on maybe a real use case. So I think those 3 steps in that order are a great way to get involved. Of course, it's not the only way to get involved. One other excellent way to get in touch with us is to reach out to us on Slack on the Alexa Skill Builder community. If you're an Alexa developer, if you're thinking about building with Alexa, if you've built lots of skills with Alexa, no matter what, really, it's where I recommend going for help, support, and community. You can find it at alexa.design/Slack. And this community is really for everyone. It has Amazon teams, it has global developers, it has skill designers, it has everybody. It's a great place, and I really encourage you to go check it out. Finally, let us know how we did today. Please follow the link shown on the slide here to our survey. Give us feedback on this talk. Was it interesting? Was it helpful? What would you like to see more of? All of the above. We really look forward to hearing your feedback and appreciate that you've taken the time to come and listen to us. Thank you again. Have a great day. And hopefully we've been able to help you out. We look forward to talking with you on Slack about ACDL.